Bismillahirrahmanirrahim. Assalamu alaikum. In the last video, we discussed the limitations of direct design method, and we have solved one example to check the limitations of direct design method for a given slab system. So in this video, we will discuss the procedure of direct design method. Okay, the first step for the procedure of direct design method is to divide the slab into panels by drawing center lines along the columns. So first of all, we need to convert our slab system into panels by drawing the center line of the column. So in this way, we will draw the center lines of the column, and between the center line of the column we will have slab panel. So this is slab panel 1, 2, 3 like this. The second step is check that limitations of direct design method. So just like that we have done in the previous video, so we will check the limitations. If all the limitations of direct design method are satisfied, then we can use this direct design method for the design of given slab system. Okay, third step is transform the three-dimensional building into simpler two-dimensional frames by cutting the structure with imaginary vertical plane along the center line of the panels in each direction. So we have to divide this, we have to convert this 3D structure into 2D frames. We will draw center lines of the panels, and in this way we will get this exterior frame and interior frame. So just like this, we will have exterior and interior frame. In case of exterior or edge frame, we will have slab only on one side of the column, but in case of interior frame, slab will exist on both sides. So this is also evident from this figure. So this is the exterior frame and this one is the interior frame. In case of exterior frame, we have columns at the edges and slab on one side. And in case of interior frame, we have columns and slab on both sides of it. So we have to divide our slab system or our structure into frames, exterior and interior. Okay, next step, fourth step is to find the column strip and middle strip. The column strips are located over the column. So column strips are located over the columns and have a width on each side of the column center line equal to a smaller panel dimension divided by 4. And middle strips are located between two column strips. For example, we have these two panels, panel 1, panel 2. And if we are considering this north-south direction, so the column strip will be this one, this dark shaded area. So along the column center line are over the columns. So the dimension of this column strip will be equal to the smaller dimension of the panel divided by 4. So for this side, for this half column strip, so this is half column strip and this one is the other half column strip. For this half column strip, we will consider this panel, for example panel 2, panel 1. So we will consider panel 2 and we will check its dimensions, panel dimension. So the smaller of these two, for example this is maximum or larger and this is minimum smaller. So the smaller value will be considered to calculate the width of column strip. So the column strip width will be L minimum divided by 4. This will be half column strip. Similarly, for the other half column strip, we will consider the first panel. So in case of first panel, again we will check which one is the smaller span. So the smaller span divided by 4 will give us the width of this column strip. So the sum of these two will give us the total width of the column strip. Okay, so here we have this dark shaded area column strip, and here for this frame we have this column strip, and in between these two, this light shaded area is middle strip. So the width of middle strip will be equal to the center to center dimension between the columns minus the half column strip on this side and half column strip on this side. So we can say if this is L2, later on I will explain what is L1 and L2, minus 1 by 2 column strip minus 1 by 2 column strip. So it will be equal to width of middle strip. Similarly, on east-west direction, the same procedure will be adopted. The column strip, this dark shaded area, half column strip, L minimum by 4. We will consider this span, span 2, span 1. So the shorter dimension of span 2 divided by 4 will be this half middle column strip, and smaller dimension divided by 4 will be this half column strip from panel 1. So in between these two column strips we will have this middle strip, and the dimension of middle strip again will be here, this one will be the total width of the frame or the width of the panel minus half column strip here and half column strip here. So the subtraction of these two half column strip from this overall width, we will again call it as L2 minus half column strip width from here and half column strip width from here. It will give us the width of middle strip. So in this way we can determine the width of column strip and middle strip. So let's solve one example just to practice and clearly understand the width of frame and width of column strip and middle strip. So the question is, find the width of exterior and interior frame in east-west direction. This is east-west direction. So in east-west direction, determine the width of interior as well as exterior frame. Second is, find the column and middle strip in east-west direction. Column strip and middle strip, we have to determine their width. And the information given is the column size 300 by 300 and the spans in north-south direction are 6 meter all, and in east-west direction 5 meter each. The spans are similar. Okay, first of all, the width of exterior frame. So this one is exterior frame. From the center line of this panel up to the edge of the slab. So this is exterior frame. And in case of exterior frame, we can see that the distance between the center line of the column up to this red line, the center line of the column up to this red line is 3 meter or 3000 millimeter. The center line to center line of the column is 6 meter, so at the half of it is 3 meter or 3000 millimeter. But we have a projection of slab from the center line of the column. So this projection is equal to actually half of the column width. So we will add half of the column width to get the total width of this frame. So 6000 divided by 2 plus 300 divided by 2, because the size of column is 300. So it is the width of exterior frame. So I can explain it over here as well. So this is our exterior column and this is the center line of the panel. So this is the center line of the column and the edge of slab lies over here. So this distance is 6000 divided by 2, half of the panel width, and this distance is equal to 300 divided by 2 because the dimension of column is 300 millimeter. So in this way we will calculate this total width of exterior frame. So the width of interior frame is from this red line up to this red line, from the center line of this panel up to the center line of this panel. This is the width of exterior frame, this one. So from the center line of the column up to the center line of the panel, this distance, as we know, it is 6000 divided by 2. Similarly, on the other side, again the panel dimension is 6 meter, so it is again 6000 divided by 2. So overall width will become 6000 millimeter or 6 meter. This is for interior frame. Okay, next is the width of column strip. So width of column strip for exterior frame. So the width of column strip in case of exterior frame will be from the edge of slab up to this one, this blue lined area. This is the width of column strip. How you will determine this width of column strip? Let's consider this first panel. This is the first panel, for example. So this is the center line of the first panel shown by this red line. Okay, so the dimension of this panel, on one side it is 6 meter and the other side it is 5 meter. So the smaller dimension is 5 meter. As we know, as we have seen in the previous case, the width of column strip is from the center line of the column, it is L minimum divided by 4. So in our case L minimum is 5, so L 5 divided by 4 or 5000 millimeter divided by 4. So it is 5000 divided by 4. So this is actually from the center line of the column up to this blue line. But we have the projection of this slab up to the face of the column. So we also need to add that portion in the column strip. So we all need to add this 300 by 2. So I can explain further over here. So here this is our exterior column like this. So this is the center line of the column. So this is the center line of the panel. And if the dimension in this direction up to center line 3 meter, but up to the end it is 6 meter. So I draw it again. So this is the center line of the column and this is the center line of the panel. So this dimension, this is 5 meter and this is 6 meter. So the Gorning value will be 5 meter. So the 5 meter divided by 4 will be up to this one. Let me change it to the red line, up to this one. So this distance is 5000 divided by 4. But our slab is projected up to the face of the column like this. So this portion we need to add this portion into the column strip. So this portion will be equal to the width of the column strip divided by 2 mean width of the column divided by 2, 300 divided by 2. So the overall width of this column strip will become 5000 divided by 4 plus 300 divided by 2. So in case of exterior frame, this extra calculation is required up to the edge of the slab. Okay, so 5000 divided by 4 plus 300 divided by 2, so it will give us 1400 millimeter. Okay, the width of middle strip, so width of middle strip will be, actually we have this distance from center line to the center line of the column 6 meter, and up to the center of the panel it is 3 meter. And from the center line of the column up to this column strip we have distance 5000 divided by 4. So if we subtract this 5000 divided by 4 from this 3 meter, we will get this distance or this width, which is half middle strip. So the width of half middle strip for the exterior frame will become 6000 divided by 2 mean this 3 meter minus 5000 divided by 4 this column strip width up to the center line of the column. So it will become 1750 millimeter. So this is for exterior frame. For interior frames, the width of column strip. So here the width of column strip is this one. This is the column strip. Area bounded by the blue line. So the width of column strip, half column strip is on this side and half column strip is on this side. So the width of half column strip on this side, on the upper side, will be the smaller dimension of this panel 1. So the smaller dimension of this panel is 5 meter. So 5000 divided by 4. And similarly for this panel, panel 2, again the smaller dimension is 5 meters. So 5000 divided by 4. So this dimension is 5000 divided by 4. Similarly, this dimension is also 5000 divided by 4. So the overall width is 2500 millimeter. So this is for interior frame. Okay. So in case of interior frame, the width of middle strip, so half middle strip lies on this side of the frame and half middle lies on this side. So this dimension up to the center of the panel from the center line of the column, this is 3 meter. On this side, again from the center line of the column up to the center line of the panel, it is also 3 meter. And we know this distance, it is 5000 divided by 4. Width of half column strip is 5000 divided by 4. So the width of this half middle strip will be 6000 divided by 2 mean this 3 meter minus width of this half column strip 5000 divided by 4. So the width of half middle strip will be 1750 millimeter. This one, and the similar will be over here, this one. So in this way we can calculate the width of column strip and middle strip. So we need to determine the width of column strip and middle strip in both the direction, east-west as well as north-south. Okay, the fifth step is For each frame, calculate the total span moment m0. So we need to calculate the total span moment m0 for the end and the interior span, end span as well as the interior span. So this is end span, these are the interior span. For each frame and for each span, we need to calculate this moment m0. So this m0 is actually a moment that is calculated based on the assumption that this span is a simply supported beam. And we know in case of simply supported beam, moment is equal to WL square by 8. Okay, so here if we see this is the exterior frame. So for each frame and for each span, we need to calculate the m0. And this is interior frame, this panel and this panel, we need to calculate the m0. Okay, here W is actually line load, because in case of beam we consider line load, which has the unit kilonewton per meter. But in case of our slab, we have load in the form of aerial load, uniformly distributed load, which has the unit of kilonewton per meter square. So first of all, we need to convert our uniformly distributed load into line load. So how we can convert that load into line load? We can convert that load by multiplying it with the width of frame, L2. So L2 is the width of frame. So we will multiply our uniformly distributed load with this L2 to get this W, line load. So uniformly distributed load, here m0, the uniformly distributed load multiplied by L2, so it will give us actually W. And the next is L. So L is actually clear span का square. So the clear span is actually face to face distance between the column. So face to face distance between the column is clear span. So it is Ln denoted by Ln. So it's square divided by it. So from here we can calculate the static moment. And this Wu is uniformly distributed load, which is factor dead load plus factor live load. Okay, one thing that you should keep in mind, the convention related to L2 and L1. So if we are considering our span in north-south direction, so this is our span length. So this one will be L1. So the length of frame, or in the direction of frame, the length will be L1, and perpendicular to that will be L2. So L2 will be the width of frame and L1 will be the length of span, or span length. So always keep in mind L1 is in the direction in which we are going to calculate the reinforcement, so the direction of frame, and L2 is the transverse dimension, and this is actually equal to the width of frame. So here you can see this L2 is width of this exterior frame, and here L2 is width of interior frame. Okay, regarding Ln, the clear span, so we need to keep few things in mind. So this Ln is the distance from face to face of the column, or column capitals, brackets, or walls, even if beams exist, and shall not be less than 0.65 Ln. What it means? For example, here we have a column. This is our slab, and here we have a second column. If there is no drop panels or column capitals, the clear span will be this one. But if there are drop panels, for example, like this, around the column, so in that case, the clear span will be this one. From the face to face of the column, or from the column capital to column capital, or drop panel to drop panel. So in this case, ln will be this one, and if there is no drop panel, ln will be this one. Okay. So if this column is not a rectangular column, so for example, here we have a circular column. So I again draw this. Here we have a circular column and a circular column. So in this case, the clear span will not be like this, from the surface of the column to the surface of column. Instead, first we need to convert this circle into a equivalent square, like this. Then the distance between the faces of these two equivalent squares will be ln. So the dimension of this one will be equal to 0.89 of the diameter or the depth of this circular section. So if this shape is not circular, some other shape like this we can see over here. If it is circular, it is 0.89, and if it is a hexagonal shape, then this equivalent square will have a dimension of 0.93, and if it is rotated square, then the dimension will remain h, but we need to rotate it. It will not be from the face, from this corner to the next corner, the clear span. Instead, it will be from the face of this equalized square to the next equalized square. So this thing should be kept in mind while calculating the clear span. Okay, so let's solve one example just to practice how we can calculate the static moment. So compute the static moment m naught for a frame spanning between the columns 1 and 2 as shown in figure. So here we have a column 1 and column 2. So between these two columns, this frame or this span, we need to calculate static moment for that. So the normal weight concrete is 8-inch thick. The thickness of concrete is given, concrete slab, and it supports a live load of 100 pound per square feet, and the live load is given. So our aim is to calculate the static moment. So we know that in case of static moment, m naught, we required three factor actually: Wu, L2, ln square divided by 8. So if we know this Wu, L2 and ln, so we can easily calculate this m naught. So first of all, calculate Wu. So Wu is actually the uniformly distributed load, uniformly distributed factor load, which is equal to 1.2 dead load plus 1.6 live load. And in our case, the superimposed dead load is not given, only the thickness of slab is given, so we can calculate the cell weight of slab. So cell weight of slab can be calculated by multiplying the thickness of the slab with the density. So the thickness of slab is 8 inches or 8 by 12 feet. If we multiply it with the density 0.15 kip per square feet, so we will get the cell weight, and we can factor it by multiplying it with the 1.2 factor. Similarly, 1.6 is the factor, and this is the live load, which is given 100 pound per square feet, and if we convert this pound into kip, so we need to divide it by 1000. So 0.1 kip square per square feet. So in this way we can calculate this QU. Okay, so next is the calculation of L2. As we have discussed in the previous slide that this L2 is actually width of frame. So how we can calculate the width of frame? So the width of frame, so if we have this column and this column, this panel, for example this panel 1 and this panel 2. So the center line of this panel is this one. And the panel width is 21 feet. And on this side the center line of the panel is this one and the panel width is 20 feet. So from the center line of the column up to the center line of the panel, the distance will be 21 divided by 2. Similarly on the other side, from the center line of this column 1 and 2 up to the center line of the panel 2. So the distance is this 20 divided by 2. So 21 divided by 2 plus 20 divided by 2 will give us 20.5 feet. So the width of this frame will be 20.5 feet, which is given over here. So this is also explained here, the width L2, width of slab panel, which is 21 by 2 and 20 by 2, 20.5. Okay, now we have calculated QU or WU and L2. The next is clear span. So the clear span is the distance from the face of one column to the face of other column. The total span, center to center distance between the column or L1 is equal to 22 feet. From the center of this column 1 up to the center of this column 2, the distance is 22 feet. And the dimension of this column 1 is 24 inches and the dimension of second column is 20 inches. So we need to subtract this half of this 24 inch and half of this 20 inch from this 22 feet. So here clear span ln, so 22 feet minus half of 20 inches, or convert it into feet by dividing it with 12. And similarly 1 by 2 minus 1 by 2 times this 24 inches for column 1. So we need to subtract half of this column width and half of this column width from this 22 feet to get this clear span ln. So the clear span will become 20.17 feet. Okay, now we have QU, L2 and Ln. So once we have these three factors, so we can easily plug in this value into the equation of static moment to calculate the static moment value. Okay, the last step is division of the total panel moment m0 into negative and positive moments and then to column and middle strip. So this distribution of m0 into negative and positive moment and column and middle strip is based on the coefficients. So these coefficients are actually given in ACI code, ACI 318, chapter number 8 and section number 10. ACI 318 8.10. Okay, we need to distribute the static moment first into the negative and positive moments, and then this negative and positive moment will be distributed into column strip and middle strip, This positive moment will also be column strip into middle strip. So the first distribution of static moment into negative and positive moment is termed as longitudinal distribution, and then this negative moment into column strip and middle strip, it can be termed as transverse distribution, and then this column strip moment is distributed into beam and slab moment. So this can be termed as vertical distribution. Okay, for this distribution, as I have told earlier, the coefficients are available in ACI code. So we will select the appropriate coefficient based on the end conditions of the slab panel, interior and exterior, and the presence of beams in between the column. So after selecting those coefficient, we can distribute this static moment in longitudinal, transverse and vertical direction. So in the next video, inshallah, we will discuss this distribution